Here's the fixture aligned in the spindle. We mount the blank that I machined in the previous operation onto it. The first tool is a CNMG turning insert to face off the part and to finish that radius on the OD there. The next tool is a 1/2-inch 4-flute end mill, standard 4-flute end mill, just to rough out the bulk of the material in the flutes here. This is a adaptive or tricoidal milling cycle. Here, I was trying to take a high frame rate. It's 120 frames per second with this GoPro camera. It'll actually go to 240 frames at a 1080p, but there isn't enough light in the machine. It's too dark in there, and you have to set the ISO up, and it gets real grainy looking. But 120 is acceptable. It's not too bad here, and I was just slowing this down to, as you can see the shavings coming off the end mill. Just playing around with the camera settings here. This newer GoPro camera, the Hero 6, is much more sensitive to the light and these reflections you can see on the metal, and when it points up towards the lights on the top of the machine, those LED lights, it kind of blows the whole picture out and it makes the focus go out of whack. Didn't seem like I had that much trouble with this with the Hero 4 camera, so I don't know. See those LED lights there kind of blowing the picture out. I mean, that's sort of understandable, but the reflections on the metal, you can see on that arbor that I got this cutter on, it's hard to get a good exposure with this camera for some reason. This is a 1/4-inch end mill. This is actually a rest machining operation. That's machining the remainder of the material that the 1/2-inch end mill couldn't get. And then I come in with another 1/4-inch end mill to finish these profiles so that I don't put all of the work on the one end mill, because it's going to wear the tip of this tool out. It's only pecking down, I think it's 100 thousandths or thereabouts each pass. And it's going to wear the tip of this tool out, so if you try to take a finished pass with the same tool, it's the end of the profile is going to not leave a decent finish. This chattered a little bit in that inside corner, but I'm not really worrying too much about it. It's just a cutter, and the finish down there isn't really critical or doesn't make any difference. I'm just slowing this down here a couple of passes. You can see the end mill cutting there. So that's that tool, and here's like I said, the second 1/4-inch end mill just does a finished pass over the same profile on each one of the flutes of the tool. Tried to show different angles of these tools. I was trying to run this mostly without coolant so we can kind of see what's happening. So if I was running normally I'd be running the coolant on these tools and you couldn't really see anything. Then this steel, you can sort of run a carbide end mill dry. It's not too bad. So this is a 3/8 ball end mill. This is just cutting a little bit of clearance on the tips of those flutes of the tool. I think it's about, I don't know, 5 or 7 degrees. Just so it's not a cylindrical shape on the OD. This may not totally be necessary, but I just did it just to be safe, so that the back of those flutes wouldn't be dragging as the cut feeds forward when the tool's doing its job. Most of the machining in this video is sped up 10 times faster than normal, in case you're wondering. This little cut is just clearance for the tools that go in and make the insert pockets. Otherwise the shanks of some of the tools would rub before it got to the outside of the insert pocket. And spot drill before the tap drill. And this is a tap drill for the 5mm thread. Couldn't run this tool dry. It was a high-speed cobalt drill. Had to run coolant on that tool. This is a little 3/16 end mill that I use to rough out the pockets. I have to really change this every part because it wears the tip of this tool out because of the long extension in this shrink holder. I'm also taking very shallow passes because I'm profiling the 7-degree angle on the pockets as well, and roughing it off so that the finishing tool, that's 7-degree tapered end mill that I ground on my tool and cutter grinder, doesn't have to take as much material. It's kind of dark in this machine when the spindle is vertical like this, and it's kind of hard to get a decent video like that. I need to figure out a lighting method of some sort for that. Here's the tapered end mill, the special one that I ground on my tool and cutter grinder to put the 7-degree taper on the pockets that matches the inserts that are going in those pockets. Here I'm trying it out. It's a little bit tight, so you have to kind of tap it out. I can't really have it that tight because when you tighten the screws, you'll never be able to index the inserts. You have to kind of beat on them to get them out of the pockets. So I reran the tool. I didn't really make a change. I just ran it, get a little more of the push off because it is sticking out quite a ways from the collet chuck there. And I tried the insert again. You can see I can put it in and pull it out without having to tap on it. And spot drill again to chamfer the hole for the tap. And put some tapping fluid on there. I can't do this with the doors open on this machine because you can't run the machine with the doors open, so I have to put it all on there before. And here's the 5mm by 0.8 lead tap for the screws for these particular inserts. I ran the first hole at the normal speed, and then I sped these ones up 5 times, I think, faster than normal. And then the last hole is at the normal speed again. So that's the finished cutter, except for a little bit of deburr.